So the r squared is the coefficient of determination. It is always represented as a percentage. So the correct script is, you would say, approximately 35% of the variation in y. So the variation in weight can be explained by the least squares regression line of height and weight. This is a script that you have to memorize, and I have not seen, but most often, this is the script that they want you to write on the AP test. Almost every free response that is in your book has something to do with r squared. It shows up a lot. They like to choose this one. I don't know why. Maybe because it's one of the most difficult to memorize, but this is the one that they like to use a lot of the time. So let me kind of explain what that means in a way that we understand. Here's all of the interpretations. Actually, we're going to go back. So let's say, does anyone remember what the r squared was from the quiz?
0.88.
0.88 or something?
0.8 something. It was 0.8 something. Hold on. It was 0.887 or 8865.
So it was 0.88, something like that, and which means it's about 88%. And what was the context of the quiz? It was
something, I don't know.
GPA, so it was number of students, and it was GPA. This was on the quiz. So if I were to put that into a script, I would say approximately 88% of the variation in GPA can be explained by the LSRL of number of students on GPA. So what that means, let me explain it, because this is something that's often confused. So that number, 88%, is the percentage that you can, so the reason why these students have that GPA, 88% of it can be explained due to the number of students in the school. The other 12% can be due to other factors, like extraneous variables, right? So what are other things that determine your GPA, besides just how many students are in the school?
Your work classes.
Like people's work ethic, how often they come to school, how much they studied. There are lots of other factors. So the number of students per school is, so the GPA can only be predicted, it's only accurate as 88%. 88% of the reason why this school has the GPA that they do is due to the linear relationship between number of students per school and GPA. That's the best way that I can explain it. And the other 12% means that it can be due to other factors. So the higher correlation coefficient means the higher your coefficient of determination, which means a stronger correlation. The weaker something is, the weaker coefficient of determination, the weaker your correlation. Therefore, so many other extraneous variables that can come into play. Yes?
So for the y, do we just put GPA or like GPA over 3.5?
You can say GPA over 3.5.
Yeah, I could do that. I would originally put GPA just GPA, but that's what it was. It was a GPA,
Yeah.
percentage of GPA
Yeah.
over 3.5.
Okay, next thing is looking at, I'm going to skip this because the squares, some of the squares of the deviation we don't actually talk about, so you don't need to know that.
Sum of squares. That sounds
Yeah.
terrifying. I'm glad we're not writing that.
We don't need to know that. That doesn't show up. It just shows you the long way to calculate your r squared. However, the reason why we don't do it by hand is because the calculator gives it to us, and we also know that the computer gives it to, or a computer output gives it to us. So we've got our slope, our y-intercept. Our y-intercept is the negative 7.69. Our slope would be the 3.234. And the r squared is our coefficient of determination. This number, what does this one represent? Remember we talked about it.
It's an 8.
Standard deviation of
The standard deviation of your residuals, or sometimes it's called the standard deviation of the errors. So you might see notation on a test or on the AP test to look something like that with like a little subscript E. That's also known as the standard deviation of the errors. Errors, E-R-R-O-R-S, that's what I'm saying. And which is the same thing as your residual. And those are just the average distance in the y direction. So if I've got a scatter plot where values are like this, it's taking all of the values of these distances, obviously the absolute value of them because you have negative distance, and then it's averaging those, and this is the number that it's calculating. The formal way to write that is the typical amount by which the observation deviates from the LSRL. This is something that you might want to add to page 99 because I don't think that it's on there. So if you are looking at page 99 a lot to memorize, you might want to add this because this could be a script that I may ask you. So it's the typical amount by which an observation, so whichever each individual data point deviates from the LSRL. It's implied that it's in the y direction, but it also doesn't hurt to say that. So in the last unit, remember how we talked about population standard deviation was just n, sample standard deviation was n-1, and that was our degrees of freedom.
Yes.
Because if you had 4 fixed test grades, that fifth one had to be, or 4 test grades, that fifth one had to be a fixed value to make that average. It's because we were only dealing with one variable. Now you have 2 variables, so you have n-2 degrees of freedom. We don't talk about degrees of freedom in this unit, but when we get to, we're going to visit this unit again, second semester. It's actually the very last one we do. We come back to this. We talk about degrees of freedom. That was a good question.
Do we ever have to plug that into that?
No, you do not. It will always be given to you in computer output. Come on, there we go. Okay. One thing I do want to talk about is an influential point versus an outlier. So we haven't mentioned too much about that. There's 2 things that they can be. Influential points can be good or bad. So I want to mention that they can be good or evil.
So it's influential if it's like.
Influential, it can positively influence your correlation, or it can negatively influence your correlation.
It's closer to the LSRL.
In this point, it's probably going to weaken it because normally your graph would have done something like this. Then we've got this one influential point that changes things. So this one might be a little evil. But when is an influential point positive? What does it do? It strengthens. Yes. If I removed that influential point, it changed it.
You won't.
I did.
Don't.
Now, an outlier is always evil. So it's always evil.
If you take out an outlier, and then you have another outlier.
So taking out an outlier will always strengthen because an outlier is the one single point with the largest residual. So it's only 1 point. Now you ask me, what if 2 points have the largest residual and they're the same? Then they would both be outliers, and that's okay. But typically we only talk about having one outlier. What is the single most point with the largest residual? An outlier can be an outlier and an influential point. But an influential point doesn't always have to be an outlier because it could be good.
Nice. So an influential point is usually way far out.
An influential point just means that it changes your correlation.
Okay, and then the outlier is just the farthest away from
Yeah, so an influential point just simply means that it changes your correlation and it changes your line of best fit. It could be in a good way or a bad way.
So how do you all of those already?
They could. It just really, like if you have a cluster of a lot of points in a central point, like, let me go back. So here, these are probably not going to be as influential as like removing maybe one of these, removing this one, removing this one. Like some are, so normally a question will say, is this an influential point, yes or no? It'll isolate one point. It won't say, here's a scatter plot, tell me all of the influential points. Okay.
Everything except the last one. Is this being recorded?
Okay, yes. Lastly, so this is when I'm talking about nonlinear data. Notice that this scatter plot has a bit of an exponential curve to it. LSRLs only will show you the relationship between linear data, okay? It only gives you the linear relationship. So if we want to transform our data to be from nonlinear to linear, we have to use we go through a set of certain steps to try to transform our data. These are the common ones. So the original equation, we just have y hat is a plus bx. Another one an option that we could use is a square root function, a logarithmic function, a reciprocal function, like a rational, or just doing the log of y. Now, let me show you kind of the steps because typically AP tests don't necessarily make you transform data very often, but it could happen. And I'll tell you the steps in which we typically go in a sequential order because you usually get to one or two transformations and then you stop.
Are we going to go over what all this log stuff is?
Yes.
For?
So typically, is residual plot scattered? No. Then it has a pattern. Then here are the steps. I'm going to try number one. Number one doesn't work. I'm going to try number two. Number two doesn't work, and I go through the list. And you keep doing that until you get a residual plot that is scattered. So let's do an example, and we're going to try the x and the log y transformation. So here's what I want you to do. I want you to put in list 1 and list 2 just normally right now.
So just want to put like from the test?
Put in list 1 and list 2.
Okay, so like from the test.
Yes.
Into what?
So put in list 1 and list 2, x's and y's.
X is for the linear regression?
Yes.
Okay, so a plus bx.
Mm-hmm.
Yay. Done.
So from here, I'm going to hit stat, calc, 8, calculate my line of best fit, my LSRL, calculate, get this. I want to check my residual plot. So second, y equals, scatter plot, L1 and resid, zoom 9.
Kind of looks like a bimodal data.
What I suck.
So this one I would consider to be a pattern. It looks like a U.
That's not the one from the quiz.
This is not the one from the quiz.
I even drew the That one doesn't have a pattern. Does that one have a pattern?
This one has a pattern.
But the one on the quiz didn't.
Excuse me. That's the hardest part.
This one has a pattern, okay?
So this one doesn't have a pattern.
But I even drew the line.
Okay,
How does this?
from here,
This is bias. Oh, this is dear.
Bimodal.
from here, what I want to do, I'm going to go with my first option. My first option is going to be x and log y. So I'm going to go back to stat, edit. I'm going to go to my list 3. And I want to create log of all of my y's. So hit enter, where you get the blinky square, log of L2.
Enter.
Calculate.
Ooh.
Here are my logs, okay? From here, if you go back to your residual plot, it has not changed them because it still has my old residuals. How do I get new residuals? Stat, calc, 8. But now instead of list 1 and list 2, it's going to be list 1 and list 3.
This thing is so annoying.
You go to list 3, highlight it, hit enter. From here, I can just go to zoom 9.
It's not even working.
Now this is
I bet
scattered.
that's a pattern too.
This is scattered.
That's
You could draw like a squiggly line.
That's a yeah. You could do it.
I misspelled scattered.
Actually, it could be a little prevalent.
Scattered.
Gonna write my LSRL as, where did it go? There it is. This. So when I calculated my stat calc 8 and I did list 1 and list 3, I got a residual plot that looked like this. This is scattered. So I'm gonna go back and rewrite my LSRL like this. So now it's log of y hat equals 1.226 plus 0.041x. So the new LSRL has a log in your y. That we're still patterned. Then I would go to the next step. And I would do log of x, log of y. So I would go to my L4 and I would do log of L1. And then I would try it that way. Okay? So on your homework, you're going to get to experience going through a few steps and seeing which one works. So you keep going through the steps until you find a function that has a randomly scattered residual plot.
So you have to do all 5 of them?
You probably will not get that far. I would say the most you probably will do is through like the 4th one. And some of them may have different answers. So if you get one that works for log y and then someone else tried a square root and they both work, then that's okay too. There's not one right or one wrong answer for all of these. Yes?
For when you're doing the stat 8, the linear regression,
Mm-hmm.
instead of like making a new list, could you just do like log of L1?
Mm-hmm. You could. So now I would say if I were to comment on this residual plot, listen, this is really important. If I were to comment on this residual plot, I would say since the residual plot is scattered or has no pattern, whatever you say, the linear model is appropriate for predicting the relationship, I said all of that to say, between, now this is where you say, you don't say x and y because it's not x and y. It's x and log y. So I would say whatever the context of my x is, I don't even know what it is, between number of days and log of average tumor volume. That's what this problem is about. So when you are, I would write this down. I don't know why nobody's writing this down. I would say that the residual plot is now an accurate predictor of the linear relationship between x and log y. So you don't say between x and y. There will be several multiple choice questions that will ask you something along those lines. And don't choose the wrong one because you will kill a puppy. So the residual plot shows the relationship between x and log y, not x and y. The last thing that they could do is ask you to predict. This is where a little bit of algebra comes in. We do get to do a little bit of math in here. They're going to ask you to predict. So what would the predicted average tumor size be 30 days after injection of cancer cells? So you're just plugging in 30 for x and you're solving for y, but there's this fancy log in front of it. So what's the inverse of log? Exponential. So I'm going to plug in 30.
Just divide by log.
No, that's not a thing. You can't divide by log. That's not a thing.
You can't divide by log.
So I've got log of y hat equals 1.226 plus 0.041 times 30. In your calculator, do that right now. So log.
Algebra. She's literally trying
I'm
to
so
get
happy that
Caleb.
Geometry.
Yay.
I'm so happy that pre-cal is like the first semester of algebra. It's so
Geometry is
hard.
better.
So log of y hat equals what?
Wait, how do you do that?
Don't do,
plug
just
in
do the
30.
right hand side of the equal sign right
Why does it plug
now.
in 30? Why is 30?
Because it asks me to plug in 30.
Oh, I didn't even see that.
So you get 2.456, is that right?
It is.
From here, I want to inverse the log, okay? I want to get rid of the log. So you do that by raising, 10 to the power. ln is when you have an e. Or e is when you have ln.
Because, yeah, why did you do that?
I just write it this way. I don't know.
You put
So y hat equals 10 to the 2.456 power.
well, I remember this.
I'll rewatch the video in a couple days. That'll help.
So 108,000.
So y hat equals 285.76 millimeters cubed is what you should get.
Okay, so